Recording. Now.
Alright, welcome in guys. Remember for today we need to do 6-7 different things for when you are doing all of these demos. So make sure you're starting by writing the title. When you see them come up in the video, it'll give you a moment to jot that down, so make sure you do that. Make sure you're reading the black, just like we did yesterday. You're making your hypothesis using if, then, and because based on what you see in the black. Okay? If you need to go through and underline your if, then, and because to make sure you have it, you're more than welcome to do that. Step 4 is to make sure you're making your observations at every single step, so when you see the demonstration done, don't just give me the observations at the end. Number 6, you're going to balance the equation, and 7, make sure you're adding your delta, your little triangle, if it's endo or exothermic. Why don't you just...
Going.
Are you ready? Okay, here we got dry ice, 70 plus degrees below zero. It goes through something called sublimation, which means it goes right from a solid to a gas, skipping the liquid phase. The any smoke you see coming off here is that gas, that CO2 coming off there. What we're going to do is put it into a cylinder full of soapy water. So we'll make a hypothesis real quick, and then here we go. Bubbles you see coming off here, full of smoke.
That's
Carbon dioxide. Fun to play with.
How long does this last?
So it's all gone. It'll go for a while. It'll fill the sink.
Fun.
That's right. You want to get a close up, you can see the bubbles coming off of it. If you look up close, you can see the bubbles. Now normally the bubbles come off there just as bubbles, but because we put in soap, it stays together and makes these. That'll go for a couple minutes with just that small amount of dry ice. Fill the sink a couple times with bubbles.
And don't they use this in off like movies and stuff?
Yeah, it's the smoke they use in movies. They don't always put bubbles though. It just makes smoke in general.
Whenever you're using horror movies, usually they do that and just like,
Yep.
ooh, it's icky
like
and
fog
eerie.
things. Can't help but play with it.
Recording.
So before we move to our next one, which is icy color change, make sure you have your hypothesis, your observations, and that you have your equation down to balance and stating if it's endo or exothermic using your delta from the lab we just did. So this new one is icy color change, and what we're going to do is add dry ice to a basic solution that has a pH of 11. So if you can remember, if that's an acid or a base, should trigger that it's a base for you. So this is our universal indicator that we're going to use. What I want you to do next then is to create your hypothesis, and I'm going to give you time to do that in a moment. and we're gonna make our observations after we do it, but you also wanna write down this equation, these two equations. So these are the two that you're gonna balance for this particular lab. So when you get done with your hypothesis, start working on balancing until we get going with our lab demo.
Now.
All right, what we've got here is just pure water, and we're going to add something called universal indicator to it. And what it does, it changes pH values from 4 to 10. So I'm just going to dump some of this in here. And you can see it's green in color right now because the water is pH 7, and that's the color for pH 7. I'm going to swish it around a little bit. And now I'm going to do is add a base. Sodium hydroxide. I'm going to add 5 milliliters of 3 molar sodium hydroxide.
Mr. Jones,
Yes.
you need to enter your attendance for today.
All right, I'll do it.
Okay, thanks.
Great. All right, so now we're going to add the sodium hydroxide to it. It's going to cause a color change. So it was green. And now it goes to a dark purple. Think like pH paper that changed to a dark purple or dark kind of violet when we did it. Next, we're going to add some dry ice to it. And then watch to see what happens. Watch for the changes in color. Think about the title of it. Oh, now it's going blue. That's going back to green. Teal. Now a lot of a light green. I'm sure it's some color I don't know.
That's a yellow.
Now we're to yellow. So now the question is, why did the colors change? Like pH change, but we didn't add any acids or bases. Good stuff.
All right, so the next one is magic lamp. Make sure you have your balanced equations from the last one and that you've added your delta for the endothermic or exothermic. For this one, we're taking some magnesium powder and we're gonna set it in between 2 blocks of dry ice and light it. So what I want you to do is make your hypothesis. Then while we're doing it, make your observations. And lastly, make sure you have this equation down because it's what you'll need to balance. And then say if it's endothermic or exothermic and put your deltas in the right spot.
The other one too, so you can see the hole.
Alright, so this is magnesium powder, and we've drilled a hole, actually like hollowed out a space in the dry ice to put the magnesium powder in. So make sure you're making observations of the magnesium powder and of the dry ice and where it's at, kind of the setup of everything. I'm also going to show you this one. So for this one, we have a little hole in the center. I know it's kind of hard to see, but if you bring the camera over, and that's where our wick is going to go through. There's a hole there in the middle. That's where we're going to put our wick. So if you just make some observations by looking at it.
Oh my God.
Oh, come close if you need to.
How fun.
It'll go for a while too. The light you're seeing is all from the reaction. That's the magnesium powder burning on the inside. The smoke coming out the top is actually a powder magnesium oxide. We just got to about 600 degrees in there and actually used the dry ice as part of our fuel.
How festive.
In just a second, we'll show you what's left on the inside when it's done glowing. All right, we're gonna take the things apart and show you what's left. See all the residue around the outside? That's the magnesium oxide, all the powder that came out. On the inside, see it kind of burned a little bit in depression and made it deeper. And then this white powder right here, that's also the magnesium oxide, and the black around the outside is elemental carbon. So any black you see in there is literally the same kind of carbon you'd find on charcoal or diamonds or anything like that underneath that magnesium oxide. So pure carbon we just made from dry ice in the inside.